Hello, everyone, and thanks for listening into our machine learning and deep learning comparisons. My name is Michael Breen. I'm a consulting engineer for the Cloud Delivered Security Services, or what we call CDSS, and Henry. I'll let you
Good
guys.
morning. I'm Henry Hernandez. I'm also with the Cloud Delivery Security Services. We specialize in the core security subs. So you look at your wildfire, your DNS, your threat, advanced threat, advanced URL, all that fun, good stuff that falls under us.
Exactly. So what we're going to talk about today is what's the difference between machine learning and deep learning,
And what is it? What is it?
exactly, and what's behind it is kind of the bigger question. I think part of it is we need a whole lot of data sets, but there is a primary difference between the two. And machine learning obviously requires an engineer to create those machine learning models, whereas deep learning utilizes something else. So Henry, I'll let you kind of go into this one here.
All right, sounds good. So here's the trick, right? So machine learning, it's been around for a little bit by IT terms. So basically, in machine learning, you have data scientists that create algorithms that help machines, right? AIs, whatever you want to call them, see patterns in events and data, and that way can call out, oh, I see this pattern, that means this, right? It has occurred, right? So basically, it helps them rapidly discover a lot of these malicious threats, right? A lot faster than human can, right? Because as a human being, we have to, go piece by piece, scanning for the data. That's the way, us old ancient SOC analysts used to do it. But now there's a better, faster way, right? It's let the machines teach the machines what the pattern is and let them find it, right? So that's kind of what machine learning is doing, right? We're teaching machines how our minds think to find these patterns, right? And we code that in algorithms and stuff like that. And now in machine learning, keep in mind, you've got to constantly massage these algorithms, right? You constantly kind of update it, tweak it, and do all that good stuff with it, right? Now, that's where a differentiator comes in with deep learning, right? So deep learning is basically where neural network systems get fed just mountains of data, and based on the mountains of data, they figure out the patterns themselves, right? So they figure out what's malicious. So the important thing to understand is when deep learning, you don't need data scientists to constantly massage and tweak these algorithms, right? The neural network features, finds these patterns by themselves, right? So because of that, it can detect all these patterns a lot faster. And that's part of the beauty of where Apollo comes into play, is the size of our data set. We'll talk about that a little bit later, but just keep in mind, the part of the beautiful part that we have is this massive data set, right? And again, we're going to talk about that a little bit later.
Yeah, and that's a great point. You have to have the data. There was actually a quote from somebody at Google that said, the more amount of data you have, the smarter you are and the better decisions you make. Yeah. And that's exactly where deep learning comes into play. So totally agree. Yeah.
Yeah. Deep learning, just bottom line, it's definitely much more effective than machine learning, right? Machines can evolve faster than our brains can figure things out, right? So it's able to adapt and find these new data sets and find new patterns faster than we can. And again, without the need of a data scientist doing that, right?
Yeah, and it's much like Nir Zook had stated years ago. He said, eventually it's going to be machine against machine, rather than people being involved. So I think that's a good point. So,
and that's pretty much it for us on that side.
Yeah, then we're done. Then we get to quit our jobs.
That's it.
But, yeah, I think point this one out is machine learning versus deep learning, and I'll start talking about neural networking.
Sounds good. So deep learning is technically a subset of machine learning, okay? But we really like to treat it almost as its own entity, just because of the way it's evolved and what it can do, and because, in my opinion at least, it's become vastly different than ML, but what we consider ML, right? So like I mentioned before, deep learning, I guess the biggest thing to always remember is, doesn't require data scientists to dictate its features, right? It comes with the patterns on its own. Okay. Now, machine learning, it's able to rapidly discover patterns, right? Identify threats. Obviously, both of these do it a lot faster than human beings can. But again, both of these require volumes of data, right, in order to be effective. especially deep learning. The more data I feed deep learning, the smarter and the more effective it gets. Let me think what else. So threat features, have to be identified by humans. They get coded in there too, right? When it comes to machine learning, and it's really most effective when you have a small subset of threat features, right?
Yeah.
Deep learning, again, subset of machine learning, right? But it requires tremendous volumes of real world threat data to be effective, right? So that's the important thing to keep in mind in here, right? Like Mike was saying, right? The more knowledge you have, the smarter you are as a human being. It's no different in this scenario, right? The more knowledge these things have, the smarter they become.
Yeah, and obviously we can learn or have both learning engines
Right.
working together, which is a bonus for us and Palo Alto Networks, and how we're starting to design our subscriptions just in general. So let's take a look at I want to say a primer, but there is a fundamental difference between machine learning and deep learning. Deep learning models use what's called neural networking. And so each one of these neural networks, which is an internal, or it takes an input and then it passes it through different patterns and matching, and it learns on itself and then determines based on things like linear process or the way that stuff is coded and what types of attacks that we can determine. And they come up with features determine if something is malicious. So deep learning is more effective than machine learning, but we need both. And when threat features are not specified within the data set, then that's where deep learning really comes into play. So if we start looking at years, actually decades ago, a simple neural network took an input layer and then fed it through a hidden layer, which did all the analysis. The problem with that was back in decades ago, we just didn't have the compute. Since we have the compute now, we can take the input layer and feed it through multiple different hidden layers and come out to an output layer, which then gives us that type of answer. So let's take a look at a picture recognition. And this is just an example. Let's say you take a whole bunch of pictures of people, and the first layer could be, I want to determine black and white colors within that layer. The second layer, which is the hidden layer, starts to look at face features or face recognition, which is the hidden layer 2, and that feeds into face recognition. And then the output layer gives me the identification of a person. So that is kind of just an example of how neural networking works just in general. So I know that's at a high level. I'm not a data scientist, but and this is why neural networking is so important, because each layer learns from the other layer and puts it all together at the very end, and then creates an output layer. So there's actually 3 different layers. There's an input layer, which takes in the information. There's hidden layers that do the compute. And then there's an output layer, which produces a result. So take it away.
Let's take a look at this piece. Right. So let's kind of recap a little bit. So, let's think about the way our industry's evolved, right? Signature based, right? Hey, I see this pattern, it matches exactly, and it worked, right? Whether it was a hash or, some kind of data element, something that identified, hey, there's Michael Breen, right? He's right there. Then obviously in machine learning, we're basically a data scientist. Well, how do you know that's Michael Breen? Well, he's this, and this, make a Michael Breen, right? And then the other one is where somebody goes, that's Michael Breen. It goes, oh, I know that's Michael Breen, without it's because he has all his data that it's gathered on Michael Breen. And it's learned that that's Michael Breen based on its own analysis of it, right?
Yeah.
So those are your deep sets. Now, let's talk about this a little bit further. So why is this so important? Why are we talking about this today? When you look at the core CDSS subscriptions, and not just the core subs, but when you look at a lot of Apollo is doing, one thing you're going to notice is this evolution to
Yeah.
this more advanced methodology, right? To leveraging of deep learning and MLs, right? To go beyond database and lists, right? Which is the classic way a lot of manufacturers do it, right? You know, manufacturers, I've worked at manufacturers, maybe some of the folks listening have worked at, you know, they've always were traditionally based on list of this, list of that, right? List of URLs, list of hash files, list of whatever, IPs, whatever it is. You know, this takes it to the next level because we're not relying on lists that are being curated by people or whatever, or data gathered, whatever.
Yeah, yeah, that's a great point. And you'll see that through our subscriptions.
Yeah.
Obviously, advanced URL is moving to deep learning. Advanced threat prevention, I believe, is moving to deep
Yep.
learning.
DNS.
DNS is still machine learning, but it's going to get to deep learning at some point. So I think that's a great point. We're kind of moving or evolving, so to speak, beyond just signatures, just machine learning, but moving more into deep learning. So,
and keep in mind, what does that mean to the customers, right? That means we're going to be more effective, right? And effectiveness is important, right? Because, you know, having been a customer, and most of us probably listen to us have been customers at some point, we expect our manufacturers' products to work, right? We don't want to hear excuses. That's the honest truth, right? We want to be able to sleep at night. We don't be stressed about things. The way we're going to get there is by greater adoption of ML and deep learning, right? The fact that this stuff can let me sleep at night because I know it's doing its job, it's learning and evolving on its own, and I don't need to babysit it and worry about it. This is where the future is going. And Palo's already well ahead of the curve. And Mike, let's bring up the fact of our data set volumes, right? The volume of data we have versus everybody else and why that's so important. I don't know if you want to take it. You want me to grab that one?
well, I think the big thing there is we collect 10 years of malware type of activity or malware binaries. We collect 14 days of benign files, but we learn from everything, and we run these deep learning models on the back end, which makes us smarter. So
Right.
it's not only just laterally looking at a specific, in this case, if you look at the HTTP stuff, we're not just looking laterally, we're looking horizontally as well. And that gives us more knowledge as to what exactly is this attack look like and how can we block this type of attack. And it just continues to grow. And with the amount of files that we get per week, through Wildfire, we learn more and more and more. So I don't know if you wanted to add to that, Henry. If
Yeah,
not,
I mean, that pretty much covers it. But I mean, just keep in mind, right? When you look at our numbers, when you think about the fact that we're in the Fortune 10, the Fortune 100 and beyond, right? When you look at the volume of Palo Alto's, you know, products that are out there in the world, feeding all this data back to us, there's no other company that can claim to have the volume of intel gathered by us. Another thing to keep in mind when you're thinking competitive too, is the fact that we're creating these algorithms ourselves predominantly, right? You know, but we're also smart enough to know when to work with other people to enhance them and make them better, right? And you'll see that when we work with chip manufacturers to update these algorithms so they work so fast. Because something to keep in mind too, because I know some people think, oh, well, all this deep learning ML, there's a time constraint to it, right? Is it going to slow down my network? Here's the crazy part. When you look at, like, let's use like you know, advanced URL as an example, right? It's able to make these analysis faster than it takes a human being to blink, right? And
yeah,
so think about that. All that data is being sent up, analyzed, and a verdict is created faster than I could take to blink, right? Because I remember, like, in the old days, and being the ancient guy that's been around since the 80s, you know, latency was always a big thing. The fact that when you look at the fact that it's doing all this work and it's doing it faster than I can blink, that's kind of mind-boggling, right?
yeah.
Yeah, and that's an important thing to keep in mind, right? So we've got all this data, all this analysis occurring. It's occurring faster than I can blink, right? We have the greatest volumes of data feeding these things, right? Especially with deep learning, like we mentioned, deep learning is based on volume of data. The fact that we have the largest volume of data of any manufacturer world, that's a key differentiator to keep in mind when you're talking to customers, when you think about stuff like this. Our volume, our intelligence, the fact that we're smart enough to know when to work with partners, whether they're chip, folks, maybe they're other data experts. A lot of other companies out there don't even write their own algorithms for ML or deep learning, right? They buy them from somebody else. We're such a progressive company. We do this internally, right? So that's another key thing to keep in mind too.
Yeah, and I think the other thing is that using neural networking makes us faster.
Yep.
And that's the whole point. That's machine against machine and learning what the attacker is attempting to do. And then from there, that's where deep learning really comes into play, because we can start to analyze exactly what they're doing, and the neural networks that are involved can come up with a signature much faster, much more efficient, much less from a benign perspective, or a false positive, I should say. And that's really where we're headed. And I think we're headed from a company perspective across every single product that we have.
Yeah. And it's not just fast, right? Because it's not just about being fast, it's about being accurate.
Yeah.
And a lot of our systems, keep in mind, have these false positive checking engines to validate a lot of these results that they're getting back. Yep. Just to basically reduce the, any chance of being false positive. So in other ways, so our efficacy is so high. When you look at like our false positive catch rate, it's normally like 0.00 something false positive possibility. I mean, basically almost non-existent. If you really think about it in the grand scheme of things.
Yeah, exactly. So, well, I think that's it for us. That was quick.
That's it. A little tease, a little quick knowledge break on what ML and deep learning is for everybody. Well, folks, thanks for your time today. Thanks for listening. Mike, thanks for inviting me on.
Thank you. No, thank you.
All right, brother.
We'll talk to you later.
Have a great one, everybody.
All right. Bye-bye.